Hello everyone, welcome to a video on the frequency response of sensors. My name is Soham.
And I am Viraj. Today we will be exploring the magnitude and phase response of two sensors, a piezoelectric sensor and a photodiode. We will also calculate key parameters like resonant frequency, quality factors, and 3 decibel cutoff frequency.
So let's dive into the procedure and results. So let's talk about the whole apparatus. So we have a signal generator which is connected to the oscilloscope, and then we have a breadboard that is connected to the speaker. The speaker contains a piezoelectric sensor. Piezoelectric sensor does is when you apply a mechanical stress on it, it converts the mechanical stress into an electrical output, which can be seen in the oscilloscope as you can see when I am putting my finger and producing a mechanical stress on the piezoelectric sensor. It takes the mechanical stress, converts it into an electrical output, and shows in the oscilloscope. So let's analyze the circuit. First, we will take the output from the signal generator, which will be given as an input for oscilloscope channel 1 and also for the speaker. An output from the piezoelectric sensor will be given to the channel 2 of the oscilloscope.
Now we will be varying the frequencies. As you can see the changes in the input and output graph, and we will record the magnitude response and the phase difference and save the value. We will repeat the same process for numerous frequencies and save the values.
From the recorded data, we will plot the graph for the magnitude response and the phase difference, and then find the resonance frequency.
Here is the data we collected for the experiment 1 piezoelectric sensor. This is the frequency. This is voltage peak to peak for the input. This is voltage peak to peak for output. This is the phase difference between input and output. And this is the gain. This is the graph between gain and frequency. And this is the graph between phase difference versus frequency. For the quality factor, Q is equal to resonance frequency by bandwidth. Resonance frequency is equal to 200 Hz and bandwidth is equal to 1200 Hz. The quality factor Q is 0.167. In task 2, we analyze a photodiode. Let's break down the circuit setup. We have an LED that emits light onto photodiode. The intensity of the light is modulated by a sinusoidal signal from the signal generator.
Now it's crucial to note that photodiodes operates in reverse bias, meaning the cathode, the side with the stripe, is connected to the negative side of the voltage source and the anode to the positive wire resistor.
Exactly. Since LEDs are diode, they are require a certain cut-in voltage to start conducting. Therefore, we added a DC offset to the sinusoidal signal to ensure the LED remains on even at the lowest point of the sine wave. This DC offset is provided by the DC power supply connected to the signal generator, ensuring the LED is always forward biased to some degree. The photodiode generates a reverse current proportional to the incident light intensity. To convert this current into a measurable voltage, we have connected a 10 kilo ohm load resistor in series with the photodiode. This voltage drop across.
Now let's analyze the circuit and procedure. From the signal generator, we take an input sine wave with an offset of 5 volt and connect it across this LED and a 330 ohm resistor, and then connect the input signal and output signal across the 10 kilo ohm resistor to the channel 1 and the channel 2 respectively of the oscilloscope. So the yellow graph represents the input signal and the blue one represents the output voltage across 10 kilo ohm due to the photodiode. Now we start varying the input frequencies and record the data of magnitude and phase difference.
We data collected for the photodiode sensor. This is frequency, this is input voltage peak to peak, this is for output, this is the phase difference between input and output, and this is the gain. Plotted for the second experiment. This is gain versus frequency, this is phase difference versus frequency, and we got 3 decibel cutoff frequency as 80 kilohertz. Thank you.